Hello, my name is Dan Hoy, and I live in Clive, Iowa. And I am a NASA Solar System Ambassador, and that means that my job is to share information about space and space exploration throughout central Iowa. Today, I'd like to talk to you a little bit about craters. Now, a crater is a hole or a dent in the ground that's made either by a volcano or by something that hits the ground. And it's the second type that I want to talk about today. Craters that are formed by something hitting the ground, and a specific kind that's caused when a rock from space hits the ground. So that's what our topic is for today. So what we will learn about is where we find craters, different kinds of craters, how craters are made, and then I'll show you how you can make and study craters at home by yourself. Then, if you're a little bit older, stick around for a little while and we'll learn a little more about these rocks that come from space and hit the ground, where they come from and what they're made of. So, let's get started. So now let's talk a little bit about where we find craters in our solar system. The ones that are easiest to find for us, because we can see them without using binoculars or anything, is on our very own moon. And here you'll see a picture of some craters on the moon. You can see that they're round and they have little dips in the bottom, and that there are so many on the moon that there's actually craters inside craters. But we find craters on all of the planets, the rocky planets that are inside of our solar system. So we see them on our moon, and we also see them on Mars. Now, this one is a picture of some that were taken by a spacecraft that went by Mars. And you can see that they look quite similar to the ones on the moon. Now, we can't see these with either binoculars or a small telescope, but spacecraft that are traveling around Mars can see them. And in fact, we see craters on all 4 of the rocky planets closest to the sun. So that means Mercury, Venus, Earth, and Mars. Now, some of the craters are quite small and some are quite large. And the very largest of them can be quite beautiful. So if I look at this next photo, this is a photo of a crater on the moon called Tycho. And you can see that it's quite large and that it sprayed out a whole bunch of rock and dust in straight lines when the rock hit the moon. And again, because this is on the moon, you can see this with your naked eye without having to look through binoculars. But there are beautiful craters like this elsewhere as well. And this is a crater that looks somewhat the same, and it is from the planet Mercury. And this one is called Kuiper. And you see the same. It's got the big hole or dent in the middle, and then the beautiful rays that string out from there. So I'll just stay on that photo for a little bit of a while. So we see craters on the 4 rocky planets, and we don't see any on the 4 planets that are outside. So that's Jupiter, Saturn, Uranus, and Neptune. Why not? Well, that's because those planets are actually made of gas. They're not solid. And because they're made of gas, when a rock hits them, it just goes deep inside without making a mark. But you might be surprised to learn that for the rocky moons that are around these planets, they have craters too. Now, I mentioned that we sometimes find craters on Earth, but not very many. Why not? Well, there are a couple of reasons. The first is that we have an atmosphere, or we have air around our planet. And when rocks come from space toward Earth, they heat up so much when they come in that air that they burn up and don't land on the ground. Another reason is that most of our planet is water. And so if something lands in the ocean, we really don't see them at the bottom of the ocean. Even when they land on Earth, they sometimes get wiped away by rain and wind over the course of very many years. So we don't see very many on Earth, but we do see some. And one of the most famous ones is actually in the United States. And it's in Arizona, and it's called Meteor Crater. It's also called the Barringer Crater. So it's in Arizona, and it has a visitor center. So if you ever get a chance to go to Arizona, you might consider stopping in there. It's very large. It's almost a mile across, and it was formed 50,000 years ago by a large iron meteorite that was about 100 to 150 feet wide. So we do have meteors that come and land on Earth as a meteorite, and once in a while, not very often, they make very big craters. So let's learn a little bit more about craters and the different kinds that we can find. Okay, so now we want to learn a little bit more about the different kind of craters you can find around our solar system. And so the one that I want to start with is the large crater. And these are the ones that can be several hundred yards across or even miles across. And they have some features that are kind of special. And so let's talk about those. First of all, one of the things you'll see about the large craters is that they have a very large, high rim around the outside, because when those big rocks come in and hit, they sploosh up all the rocks that are around the outside and make a ridge that you can see afterward. Another thing about the large craters is that the floor of the crater is usually pretty flat. And the reason why it's flat is that after the big rocks hit, the rock inside there actually melts. And so it melts, stays flat, and then forms that way. Another thing that's really common about these large craters is they have this peak in the center. And if you've ever seen when you drop water into a pond or into something else, sometimes when it splooshes up, you'll get that little peak coming up in the center of a drop. That's kind of what happens here too. The rock splooshes up and then hardens. Something else you'll notice in large craters, and we talked about this before, is that they splash so much rock and dust after they're hit that rock goes out in these long straight lines called rays. And those rays can go from hundreds of feet to hundreds of yards to sometimes miles and miles, like the photos that we saw of Tycho crater on the moon and the Kuiper crater on Mercury. So that's the large craters. They're really beautiful. What's more common though, when we look at craters, is that they're just kind of the common craters that we see here, and they have some differences. The first is that their walls are usually not as tall, and sometimes there's really not much of a wall at all. The other thing that you'll find that's different is for the very small ones, in fact, is that they're not really flat on the bottom. They're kind of hollow and round on the bottom. They also don't have central peaks in the middle, and you also don't see rays. So that's kind of the more common crater that we see more of. And then just a few more. So there are some special or unusual craters that we see sometimes as well. And this first set is what we see a lot on the moon and the other bodies that get hit by lots and lots of rocks. And that's simply that you have craters that are inside craters that are inside craters. And in fact, when they brought the moon rocks back from the moon, they found very, very tiny rocks that they brought back that even had craters in them. A second kind of unusual crater is not round, but it's oval. And the oval craters happen when the rock doesn't come straight in, but it comes from an angle and scoots across the surface, carving out a long, hollow crater. And then a third kind of unusual crater is called a chain crater. And this is what you'll see in a chain crater, is a whole series or line of craters in a row. And this is what happens when a meteorite is coming in and breaks apart before it hits the surface. So one part hits here, next one there, next one there, next one there, next one there. So that's a little bit about the different kind of craters that we can find where we find craters. And then the next thing, I'm going to show you a little bit about how you can experiment at home and make your own craters. Okay, now here's the fun part about how you can make craters and study them at home. So most of these things you can find around your house, and it's really a pretty easy thing to make. So let me go through it with you. The first thing that you will need is something to put under all of this, because honestly it can get a little messy. So I usually just unfold a plastic bag and put it on the table and then build everything on top of this. You can use whatever you want, but this I can use, and then I can usually wipe it off and use it again later. Second thing you need is some kind of a pan. It's nice to have a pan that kind of has some high edges because it is going to sploosh out a little bit, and you want to make sure that you can make as little bit of a mess as possible. So this is a 9x12 baking pan. Sometimes I use a disposable one like this, but you don't have to. You can use a regular baking pan and clean it up and reuse it without making any waste. So then the first actual ingredient is baking flour. And so this is just ordinary white all-purpose flour. You'll use about 4 cups to fill a pan like this enough. And I don't buy any special kind of flour. In fact, for this kind of thing, I just look for the cheapest flour that I can find. So spread that out as evenly as you can in the pan. Then the next thing, and you don't have to do it, but the next thing I usually add is some colored sprinkles, and I just sprinkle these all over on top of the flour. And they will act as the rocks that are getting blown around by the crater when it's made. You can use any kind of sprinkle you want, any kind of color. I just suggest that you don't use chocolate sprinkles because you really won't be able to see them because we're going to put some cocoa on top. And so that's the next and final ingredient. After putting on maybe a couple of tablespoons of those sprinkles, then somewhere around 3 or 4 tablespoons of cocoa. And once again, I don't use expensive cocoa for this. I usually look for the most inexpensive that I can find. And so if you have one and you can use it, it's usually easier to sprinkle this cocoa on top of the flour using some kind of sifter like this. So I just put the cocoa inside there and then sprinkle it all over the surface. You don't have to get all the way to the edges, but try to get as close as you can. So that's our planet surface that we'll use for our crater studies. And then the next thing you'll need to act as the rocks coming in and hitting are some rocks or some pebbles. And so you'll see here, I have an assortment of rocks, some kind of small, some kind of large, because it is interesting to see the different kinds of craters that are made by small objects and large objects. And that's all you really need. Now, if you're doing a little more scientific study at home, another thing that you can consider adding to this is a ruler. And what do I use a ruler for? Well, I get some note paper, and just so I can study a little bit more about craters, I can measure how high I'm dropping the rock from, because you'll find that that makes a difference. And the other thing is you can measure how large each of the craters are. And that also is kind of interesting to see what size of rock makes the biggest crater and how much difference is the size of the crater if I drop from a low height or if I drop from a really high height. And so that's all you need. So I've made up one of these, a little tiny one, and I'll demonstrate kind of how that works for you in just a second. Okay, demonstration time. So I've made my own small sample of what you can build at home, and I'm going to show you a little bit about what you should expect to see when you have your first asteroid hit, making a crater. So I'm gonna get a stone, you can see, not very large, one of the larger ones that I'll probably use though, and we'll go ahead and we'll drop it from a height of maybe about 1 foot, and hopefully we'll see what happens. So here we go. There's the crater. So if we look down deep inside, what will we see? Well, first of all, we see that it made a hole. So that's number one thing about a crater. The next thing is you'll see that some of the candy sprinkles that I put inside shot out of the crater when my rock hit. And so think about that a little bit. Do you think you'll find more of those sprinkles close to the crater hole or further away? That's something you can look at. The other thing that you'll notice, and it's caused by the flour that was deep underneath, is that we got rays forming. So when the rock hit, it penetrated, went through the cocoa, hit the flour level below, and sprayed it outside the crater hole. So there's a ray, there's one, and there's one. So that's how at home you can learn how to make your own craters and learn a little bit more about what makes a difference. Size of the rock, how high it's dropped from. Hope you have fun with it. So now we've learned about craters and how they're made, what types there are, and even found a way for you to make them and study them at home. I hope you have some fun with that. But now let's learn a little bit about these rocks that make these craters, not only in our solar system planets, but also some of the moons of the gas giants. So most of these rocks that we've been talking about come from an area in our solar system called the asteroid belt. And it's an area of large and small rocks that orbit the sun between Mars and Jupiter. Scientists think that maybe at one time there could have been or should have been a planet there, but for lots of different reasons, they never got together to make a planet. So now we just have these rocks. What about them? Well, not surprisingly, they're called asteroids because they're in the asteroid belt. And an asteroid is simply a rocky or iron object that's in space. Some of these are quite large and some of them are smaller. The largest one we know is actually called a dwarf planet or minor planet, and it's called Sirius. And it's not this one because it's round, it has its own craters, and it's about 600 miles across. Well, how big is 600 miles? It means that if we brought Sirius down to Earth and we put one edge in Des Moines, Iowa, the other edge would be at about Detroit, Michigan, if that means something to you, or going in the opposite direction, it's about the same as the other edge being in Denver, Colorado. So it's large, but most of them are not large, and in fact, a lot of them are quite small. And asteroids that are smaller are often called meteoroids. And they can be anywhere from kind of the size of a car down to very small, like a garden pea or even a speck of dust. And there are millions of asteroids and meteoroids in the asteroid belt. Sometimes, although most of the time they just orbit calmly around the sun like us, once in a while they get pushed around by the gravity of the other planets and they head toward the sun. And as they're heading toward the sun, sometimes they're in our way as we go around the sun. And when they do, you'll sometimes see what's called a meteor. And this is formed when a meteoroid comes into contact with the atmosphere of Earth. And because they're going very, very fast, and because the air resistance slows them down, they get quite hot and they'll even get bright. And so you'll see these bright streaks of light across the sky. Some people call them falling stars or shooting stars. Yeah, they were called that a long time ago, but we know now that they're not stars at all. They're pieces of rock from the asteroid belt. Most of them burn up and we never see them come to Earth, but every once in a while they're large enough that they do make it down to Earth, and they're found by scientists. And scientists are very interested in meteorites because they come from some of the oldest parts and the oldest rocks in our solar system. So we're very fortunate that we don't have to go there to find them and study them, because we just have to find them here on Earth. So there's three different kinds of meteorites, and we'll talk about them next. Okay, in our final section today, I want to talk a little bit about the three general kinds of rocks that are found in the asteroid belt, the three kinds of asteroids and meteoroids that are found there and then on Earth. So the first kind is called the stony meteorite. And this is an actual meteorite that landed in the Saharan desert of Africa and is one of the more common types called a stony meteorite. Now, it looks like a stone because it is very much like the stones that we find on Earth. However, if scientists study these, they'll find that the kinds of rocks and the kinds of chemicals in those rocks is quite a bit different from what we find on the surface of the Earth. Another thing that's kind of interesting about almost every meteorite is that it's magnetic. So if I put this magnet on top of this meteorite, it's stuck. And that's because it does have quite a bit of iron in it. It doesn't mean that every magnetic rock is a meteorite, but it's certainly one of the first tests that's ever done to see if you might have a meteorite. So that's a very common type. It's called the stony meteorite. Another type that's maybe not quite as common is called the metal meteorite. And I think it's fairly obvious why it's called that, because it is almost all iron and nickel. And you can see that it's quite shiny, and you can see how it kind of melted as it was coming in our atmosphere before it landed on Earth. And these are not just magnetic. These are like super magnetic, right? And so not only does the magnet stick to it very readily, but it's actually a little bit difficult to get off because it has so much magnetism. Then the third type that I'll show you here is actually more rare and really, really interesting. This is called a stony metal meteorite. And I think it's kind of obvious why, because it has both metal, the shiny part in, and stony, because you can see the bits of rock in it. And scientists think that these happened when the metal ones ran into the stony ones in the asteroid belt. They may also come from some very early almost planets from the very edge of the metal core where it turned into the rocky mantle. These are very magnetic too because they have so much of that iron and nickel in them. So those are the three kinds of meteorites that we find on Earth. There's all sorts of little subdivisions of different kinds within each of those, but the main types are stony, metal, and stony metal, or iron or stony iron. They're called both. Hope you had fun taking a look at part of my meteorite collection. So that's it for today. I hope you had a lot of fun learning about craters everywhere, that you do some of the exercises at home to learn even more, and maybe we'll see you again sometime. Bye for now.